Page 30 is more translations. We're going to do so much translating that you will never ever forget it. It will be stuck. Number 1, we'll do 1 together and we'll do the last 2 together. 2 times the sum of a number and 5 is 26. What is the number? 2 times the sum is. So we're going to multiply 2 times the sum. Remember, sum means the answer of addition. That means we've got to find the answer first. Therefore, first thing we're going to do is add a number and 5. 2 times that. 2 times the sum is, I always like to do one side of the equal sign and then the other side of the equal sign. This one's pretty basic because this side of the equal sign is just a number. Many times you'll have something complicated like this on both sides. What is the number? Now we'll solve this. I've shown you before a neat method for doing this, and this is what I want to do. Notice you've got 2 times all of this. If we want to get rid of that 2, and it's 2 times, we'll divide both sides by 2. That crosses out, and you're left with n plus 5. I'm going to rewrite what I have now. I'm going to write it up here. N plus 5 equals 26 divided by 2 is 13. Now I'm left with that. That's a much simpler equation. The next step is to isolate the variable. I will subtract 5 to get rid of the 5. Leaves me with n equals 13 minus 5 is 8. 2 times the sum of 8 and 5 is 26. Let's try it and see if that's correct. 2 times the sum of 8 and 5 is 26. Well, now we can go ahead and add these because they're both the same type of term. 8 plus 5 is 13. 2 times 13 is 26. So we have 26 equals 26. So, yep, the answer is 8. Let's go on down to 6 and 7 and do these together. 2/3 of, remember of is times, a number increased by 3 is 11. What is the number? Okay, here's our is. 2/3 of a number. 2/3 of, that means times. Increased by 3 is 11. What is the number? So, the first thing we're going to do is get that by itself. In order to get that by itself, we will subtract 3 from both sides. Minus 3, minus 3. That leaves us with 2/3 n equals 8. Now you're probably wondering what we should do. Well, what I'm going to do, you see that n? I'm going to put it up there with the 2 because it's a whole. You know, in other activities where we've been finding the slope, we've been putting equations into slope-intercept form, and we start off with something like this, we can turn it into this. Now the n can only go on the top. You can never put it on the bottom because then it would be like a fraction. But when it's written like this, you can take that n and stick it on the top. Now I'll rewrite it, and I have 2n divided by 3 equals 8. Now it's a lot easier to see what I do. If I want to get 2n by itself, I need to get rid of the divided by 3. The opposite of divide by 3 is times 3. So we'll multiply both sides by 3. We do that, that cancels out, and we're left with 2n. So 2n on this side equals 8 times 3 is 24. Now we divide both sides by 2 to cancel out the 2 times n. We're left with n equals 24 divided by 2 is 12. There is another common way to solve an equation like that. If you have 2/3 n, the goal would be to get rid of the coefficient so that this is just 1n. What can you multiply 2/3 times to get 1? Do you know? How about its reciprocal? 2 times 3 is 5. No, 2 times 3 is 6. 3 times 2 is 6. And you get 1. So the other alternative is to flip this and multiply both sides by the reciprocal. Then that cancels out, and you're left with n on this side equals, then you multiply that out. We'll just kind of draw that. 8 times 3 is 24. 1 times 2 is 2. N equals 24 divided by 2, which equals 12. This is the more common way to do that. Whichever way means more to you is the way that you are welcome to solve it. Number 7. 10 less than 2 times a number is 24. Here's my is. 10 less than 2 times a number. Okay, less than changes the order. So 2 times a number less 10 is 24. The first thing I want to do is to get the variable term by itself. So I'll do the opposite of this, which is plus 10 to both sides. That leaves me with 2n equals 35. I will divide both sides by 2. Looks like I am not going to have a whole number for an answer. That cancels out, and I have n equals 35 divided by 2. Let's think. 2 goes into 34 17 times with 1 left over. You might also choose to do long division. You might have chosen to do it like this. 35 divided by 2. Two goes into 15 7 times. We have a remainder, so we'll put it. 2 goes into 10 5 times. 17.5. Both ways will get you the same answer. Now, some of these equations may be a little bit more difficult to solve. It's okay if you have a hard time solving the equation, especially if they're ones like this that you haven't encountered before. The most important thing I want you to get done on this page is to write out the words in math. Translate them into math. I want you to do that correctly. The ones that I left are much easier than this one right here. So I don't think you'll have an issue. However, if there happens to be one and you're having a hard time solving it and you just can't get it, that's okay. We can go over that. The most important thing, like I said, the most important thing is the translations that you do. Now, on to the next page. This is a pretty basic page. There's not much new, but there's content on here that you have not seen in this context, in this book. You've done it elsewhere, so I want to make sure that you recognize it for what it is, something that you've done before on different assignments. I know when you first learn something and you see it in a new place, sometimes it can be confusing, so I want to make sure I go through these with you. We'll do number 3, -1/2 times -14. So we'll go ahead and write this out. -1/2 times -14 over 1. I'll put that in decimal form. So I've got 2 negatives. I always like to put that second negative in parentheses. You could choose to put them both in parentheses. But definitely the second one I prefer. Anyhow, this is a negative times a negative, so our answer will be positive. So just keep that in mind. 1 times 14 is 14. 2 times 1 is 2. You know, in retrospect, I could have cross-reduced. I didn't notice that. 14 divided by 2 is 7. So basically, think about this. This is 1/2 of 14. And we know that 1/2 of 14 is 7. Remember, times and of, they mean the same thing. So you can look at your answer and think, does that make sense? And when you say it like that, 1/2 of 14, yes, that makes sense. Actually, it's -1/2 of -14 is positive 7. Take a look at the next section right here. We're going to do variations on 7, 8, and 9. And then you can use that to do them yourself. Number 7, we've got 4 cubed divided by 3 cubed. We're going to do 5 squared divided by 4 cubed. Basically, you've got 2 different bases. You've got exponents that you're dividing, but 2 different bases. You solve it differently if you have different bases. So we'll do this one. 5 squared is 25. 4 cubed is 64. Now I'll just treat that like a fraction. 25, 64. Can I reduce it? No, I can't. It's not reducible. Is it an improper fraction that I can convert? No, it's not. So then I'm done. When I look at this, 4 cubed and 3 cubed, I know the top number is going to be bigger than the bottom number. So you will have to convert that into a mixed number when you finish. Maybe a mixed number, maybe a whole number, but it's definitely more than 1. Obviously, you don't have to write these because this is not the work that you are assigned. I'm just demonstrating, watch, and then you can do these based upon these examples. This right here is something you need to be mindful of. This exponent is everything inside the parentheses. There are 2 things inside the parentheses. There's a negative and there's a 7. So this is -7 times -7. That's what that means. -7 times -7 is positive 49. This one right here, that 2, that square is only the 7. It doesn't apply to the negative. It only applies to the 7. So you end up with the negative by itself. You only have it 1 time, and then you have 7 times 7. You're squaring the 7, you're not squaring the negative. Because of that, your final answer is -49. You see the difference? Be really mindful of exponents because they only apply to what is immediately in front of them. And if it's in parentheses, then it's that whole group. But if it's not in parentheses, it's just that. You see the difference? Take a moment and make sure you understand. Down to 11 and 12. Once again, I have samples. I have 1 sample for 11, 2 samples for 12. This is negative square of 121. If you're not sure what that is, think, okay, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and keep going. You know that 10 squared is 100. This is bigger than 100. So the final answer will be bigger than 100, except that it's negative, so it'll be smaller. Now, I have the square root, I have negative square root of 64. I'm finding the square root of just the 64. So when I'm finished, that'll be 8, but I still need to bring down the negative. So the value of that is negative 8. This is fun. It looks a lot more complicated than it really is. You've got the cubed root of 1/27. I have 2 examples. The first one is the square root of 4/9. What I did with that, actually I'll just go ahead and show you both of these. I have what that means is the square root of 4/9 is basically the square root of 4 and the square root of 9. Whenever you simplify something like that, you write it like this, and then you can see and do each number individually. So this is the cubed root of 8/64. So I rewrote it so it's easier to simplify. Really what that means is the cubed root of 8 and the cubed root of 64. So now I'll do each of these. The square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 squared is 9. Now we have cubed root. All right, so the cubed root of 8. Oh, what is that? To find the value of these, I'm making myself a little reference chart. 1 cubed would be 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 times 2, which is 8. Haha. 3 cubed is 3 times 3 times 3, which is 9 times 3, 27. 4 cubed is 4 times 4 times 4, which is 16 times 4, 64. 5 cubed is 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. So there's my little reference. If I have to go past 5, I will, but I'm just going to start with this. Let's see. I have the cubed root of 8. Well, that's 2. Then I have the cubed root of 64. Oh, that's 4. Oh, I went higher than I needed to, see? Huh. So I'm left with 2/4, which is reducible to 1/2. So the value of the cubed root of 8/64 is 1/2. What do you know? I'm going to write this so that it's more obvious what the answer is. You would never look at that and think 8/64, 1/2. Sure. It works differently when you're finding the roots. Finally, let's move on to 15. We'll do this one together, and then you can do 13 and 14. I think that you probably don't need my help on this, but just in case, we'll do it, and the other two you are totally on your own. I'm going to do the first step of this and write it here, and then after that I'll write it below. 9 minus 7 is 2. We do parentheses first. So now I have 3 squared times 2. 3 squared times 2. Okay, 4 times 2 is 8. So I have 16 divided by 8. So now I'll take my next step here. 3 squared is 9. So now I have 9 times 2 over 16 divided by 8 is 2. When I multiply those out, I get 18 halves, which converts to 9 wholes. So the value of all of that is 9. Let's look at the last page. The only thing I will do with you on this page is give you 2 examples to go along with these 2. And that's it. You can do the rest on your own. You can do those on your own. Just in the slight change that you don't remember, I'm going to show you examples, and that's it. Notice how just the p is squared. So when I substitute 3 for p, only the 3 is squared. I end up with 9 times 3 squared, which ends up being 9 times 9, which ends up being 81. Both of these have 9 and p and 2. 9p and 2. Both of them, it's times and an exponent, times and an exponent. But because of the parentheses, you'll have different values at the end. Here, when I substitute 3 for p, I'm squaring them both. 9 times 3 is 27. 27 squared. I already solved 27 squared right here. That's 729. The value of 27 squared is 729. Go ahead and finish these pages, and you are good.